Hello to all the Harvard audience. I am Fatima Malikipur. I'm a postdoctoral research fellow at the University of Melbourne, and I am also a member of Meet the First Author Committee at Hubble. I'm here today with an edition of Meet the First Author with Dr. Stephanie Teeter, and we will be talking about their paper titled Assessing Changes in Attitudes Toward Engineering and Biomechanics Resulting from a High School Outreach Event, which was published in Journal of Biomechanics. So, Steph, welcome to Hubble.
Thank you. And I don't want to mislead your audience. I'm not a doctor yet.
Oh, sorry. Okay.
That's okay. I appreciate the promotion.
Thank you. Okay, so to start with, could you tell us a summary of your work and how it fits into the big picture of your field?
Yeah, well, so if you don't mind, I'll talk about my background first for like 30 seconds.
Definitely, because this is bridging between two very different disciplines, so definitely go ahead.
Yeah, exactly. So I work in biomedical engineering department at NC State, and the lab that I'm in focuses on biomechanics. In addition to that, I'm a part-time graduate student in science education. That's why I said I'm not a doctor yet. I will be, but I'm not there yet. And so with the science education focus, we had this outreach event for, promoting biomechanics called National Biomechanics Day. And I was interested in looking at it from, an education standpoint. Can this event have an impact on the students and their perceptions of biomechanics? So I guess broadly, in the US at least, I don't know about internationally, there is a need to attract and retain high quality students to engineering, as well as to diversify the engineering field. Most students in engineering are in mechanical, civil, electrical, something of that sort. And so there's a need to diversify the field. Biomechanics is an excellent emerging field that incorporates, it's incredibly multidisciplinary. It incorporates, physics, math, anatomy, chemistry, biology, engineering, all of these things. And so National Biomechanics Day is an outreach event that was started about 4 years ago to target high school juniors, which would be ages 16 or 17, to expose them to biomechanics before they enter the university. So we designed our event as like a kind of science fair or engineering expo. There is research that shows that these types of short duration events where people are only there for a couple hours and only have short interactions can actually change attitudes toward the subject, even though it's very short duration. So we took that approach to our event. We also, there's also research that shows that learning is more effective when it's self-directed, by which I mean you choose what you want to learn, as opposed to being in a classroom and being told what to learn. When you are able to choose what you want to learn, there is evidence that you will learn more effectively that way. So to that end, like I mentioned, our event was kind of an expo, and we encouraged the students to go to whatever activities piqued their interest. We didn't tell them that they had to visit every station or that they had to rotate at a certain time. Instead, we said, go where you want, spend the time you want, have fun, see some cool things. And so we looked at this using pre and post surveys. So as soon as the students got to campus, we gave them a survey, and then right before they left, we gave them more or less the same survey just to see, if we had any changes in those attitudes. And we showed that following the event, so in the post survey compared to the pre-survey, they had more positive attitudes towards the field of biomechanics and also engineering in general, which was very exciting for us to see. Events such as these are highly replicable, meaning they're not a huge time commitment. They're also relatively inexpensive to host. you know, especially if you have a university who's willing to give you some space. But they can still have measurable impacts on students and their, you know, attitudes towards biomechanics, engineering, all of those things. So, you know, this has implications for attracting students to the field, which, you know, certainly would help with diversity, awareness, all of those things that, you know, we need in science.
This is awesome. Yeah, this is definitely something unique and very important, I guess, to the field. And yeah, this is lovely that you're starting at a very early stage at the highest school rather than, you know, leaving it, pushing it out to the very latest stage. Sometimes biomechanics could be very specific and people don't even come across knowing what it is until a very later stage. And yeah, that's very nice. So you mentioned some activities. Yeah, go ahead.
Yeah. So I actually will share my screen with you because I have a few activities. Share screen.
So how many students did you actually get to participate?
Yeah, so we had about 200 students overall from 7 schools. The schools were for within about an hour to an hour and a half radius, so they were not all immediately local. We had about 75 scientists participate, created about 25 different activities for the students to check out. Here's just some photos of a few of the activities. So one activity talked about motion capture. This was done, it was actually very cool to see because you would have all this, the computer close their eyes and then all the students would point at where if you can see my cursor, where this white ball was, and then the computer would open their eyes. By their eyes, I mean the person holding the computer sign, and try to guess where the white ball had been based on where everyone was pointing. And so one cool thing about this with motion capture is that it shows that you need multiple cameras, because if you have one camera with one person pointing, you don't know what they're pointing at. If you have 2, you still don't know. And so we showed them by having, you know, 8 or 10 cameras, you can tell exactly what they're pointing at. So that was a great big group activity. You know, we also talked about 3D printing, which is something that we use in biomechanics, you know, to 3D print parts, obviously, but also we have a bio printer to, you know, 3D print with different tissues. That is not this photo. This photo is just a normal 3D printer. We also talked about mechanical testing. So here we have a 3-point bending apparatus, and it might be hard to see, but there's a chicken bone on there. And so we can measure, you know, force displacement, yield point. And it's just kind of fun for kids to see chicken bones being broken. Don't worry, they were cooked. We did not use raw meat. We also talked about prosthetics design. So you can see here that she has a prosthetic on. It's not the best angle on the photo, but, you know, to have like assisted prosthetics that, you know, help with your gait, with your step. And the students, you know, were actually able to try some of those on and use them, which is very, very cool for them. Excuse me. We also had some activities talking about nano fabrication. So, you know, nano, like fabrics with like nano properties and, you know, other things that can be done with those properties. And then we also had a virtual reality activity. This one is a food fight, which of course is not very scientific, but you can see how you can use, you know, virtual reality to model human movement and whatnot.
So these are sort of activities that you that's awesome. Great.
Yeah, I mean, obviously this is not all of them. These were just a few.
Great, thank you very much. So what was the main finding actually? What did you find and learn from this study, most importantly?
Yeah, so the main finding was that this event that seems to the participants, both the scientists and the students, seems to be just a fun field trip, also actually is changing them. They, when they got there, most of them had not heard of biomechanics. Or those who did sort of had this impression that it was something really hard or complicated or boring. And after this event, their attitudes toward biomechanics actually improved. They saw things as more interesting as opposed to boring, or more easy isn't the right word. I'm forgetting the word right now, but more doable as opposed to difficult.
Exactly. Not something that they could achieve or something. Yeah, far-fetched.
Yeah. Because we oftentimes with outreach, we as scientists, we have the perspective that we want to teach people. We want them to go away learning about biomechanics, which is wonderful. I'm not downplaying teaching people, but when you have 3 hours to interact with 200 students, you can't teach them a lot. You just can't. Yeah. And so, this event showed that simply having some fun and doing some fun activities, they were like, this is cool. And then be like, oh, hey, this is biomechanics. So they left with a more positive attitude that hopefully down the road will lead to them asking their teachers about biomechanics. And then maybe they go to college and they're like, tell me more about this biomechanics thing. So, I would love to see those kinds of downstream effects from, like I said, such a short event.
Yeah, that's great. So I would imagine that you would have some challenges working for students. Is that right? Did you have any, and how did you overcome them?
Yeah, well, so our biggest challenge actually was that we had far more students interested in coming than we could really accommodate.
That's great.
I mentioned we had 25 activities and about 200 students. I would have much rather had 50 activities for 200 students. But, recruiting scientists can be tricky. They have way too, especially grad students, I shouldn't say especially, all levels, scientists have way too much on their plate. And so, asking them to take a day out to hang out with high school students is not always easy to convince them.
I totally understand.
We all understand, unfortunately. So I think the biggest challenge was, initially we had maybe 15 activities, 15 or 20, and then we had 200 students. So we're like, oh my God, what else can we do? And I mean, we reached out to the whole department as well as other biomechanics related labs. And so, it wasn't strictly biomechanics, but I mean, ultimately what we would love to do is to make this like an engineering expo where it has all branches of engineering, and maybe we can be in a section that's biomechanics, and then there can be another section that's electrical, and, and have, 100 scientists have, 500 kids.
How did you manage to get people to contribute and trust them?
A lot of begging.
Okay.
Also, for several people, my boss and co-author, and Dr. Husseini and I designed some activities ourselves and said, we have this activity, we have the materials, we just need you to run it. Can you take 3 hours out of your day to run it? And so eliminating that barrier of creating an activity certainly helped.
Okay, great. Thank you very much. Keep the nice work going, even despite all the situation. I guess the online training and everything is also providing a new avenue for all of us. So hopefully we will see more from you and encouraging our scientists into coming to education. Okay, thank you very much. Thanks.
Thank you.
Yeah, you're welcome. Thanks all the Hubble audience as well. And if you would like to get more involved, please feel free to contact us as well. Thank you. Have a great time.